Welcome, Hornets. We're going to be taking a look at expanding and condensing logarithms today. So let's just take a look at what that means. To expand is to take a single logarithmic expression, such as a natural log of x times y, and expand it into a multi-logarithmic statement by using sums and differences. So we're just moving from a single logarithmic term to a larger logarithmic term. That's expanding. Condensing. Condensing takes a multiple logarithmic statement. Let's just go ahead and throw something out, ln of y. And now that I have this, I want to condense it. So that's going to be the natural log of x minus the natural log of y squared, and then the natural log of x divided by y squared. Okay? So that's our goal. Our goal is to be able to expand and condense. Let's take a look at an example. We're going to be taking a look at the natural log of x times the square root of x squared plus 5. Now in this we have several pieces. We're going to start off with the product right in between. So I have the natural log of x plus the natural log of. And I want to convert this into an exponent. Please be aware you do not want to have radical form when you're dealing with expanding and condensing. Ultimately, you're trying to get rid of any radicals in that expansion, and at some point you're going to want to get rid of the radical as you condense until the end, and then put the radical back. All right, so here we go. Power moves in front now. Now, some people are going to want to distribute that natural log in. It does not from the front. Only when we're dealing with natural logs from the back being distributed forward. Okay, so just be aware. I guess actually it'd be distributed backward when you think about it. But that's okay. So here is our expanded form of that problem. Let's take a look at another one. Let's take a look at the natural log of x, y divided by 2. Here we have a product and a quotient. So it becomes the natural log of x plus the natural log of y. The denominator becomes a minus the natural log of 2. Notice, not difficult at all, but it does require practice. Let's look at one more, and then we're going to take a look at condensing and working in the other direction. So I'm taking the natural log of the square root of x minus 1 over x. We have to be careful. That radical is a fraction, a rational exponent. That's going to come out in front. So we have 1/2 the natural log. And we have our x minus 1 over x. Now going to break that division into a minus. 1/2 the natural log of x minus 1 minus the natural log of x. I now distribute to be 1/2 natural log of x minus 1 minus 1/2 the natural log of x. That's our goal. That's what we're looking for. All right, thank you very much. Let's now look at the condensing process, shall we? Now, condense is exactly what it sounds, going in the opposite direction, trying to find out what something is. So let's take a look at something like 1/5. We're going to put brackets 2 natural log x minus 1 plus natural log of x, so similar to what we were looking at. And then we're going to minus the natural log of x cubed plus 1. Okay. So we're going to have to start by recognizing that this is going to be a 1/5 power over all of it. 2 is going to come into the front. This plus represents a product. The minus represents a quotient. I'm going to do that first. Natural log. It's a fraction. Quotient goes on the bottom, x cubed plus 1. In the top, we have x times x minus 1. We now move the fifth root. We have the natural log for the fifth root of the fraction, x squared minus x over x cubed plus 1. That's our goal. That's called condensing. So we have applied each of the three properties of logarithms and worked ourselves from a multi-logarithmic statement into a single logarithmic statement. Let's do just one more. Let's do 1/2 the natural log of 3x plus 1 minus the natural log of x plus 2. Notice the 1/2 is no longer outside of brackets, so we're looking at a quotient because of the minus, x plus 2, and then we have the square root of 3x plus 1 in the numerator. This is then our answer from a multiple log statement into a single log statement. Notice how the expanded form didn't have any radicals, yet the condensed form does. Thank you. Be well, ladies and gentlemen, and gentle folks, and Hornets students. Thank you.